Hey there, Python pioneers. In this video, we will be coding the rock, paper, scissors game. So we're following along with Automate the Boring Stuff. If you're just hopping in or you're not tracking on where we should be, this is part of a video series. And we've learned everything we need to make rock, paper, scissors at this point. So you might read in Chapter 2 of Automate the Boring Stuff and see that there is a rock, paper, scissors game already coded out for you. I thought it would be helpful if we coded that together, and there's an important thing you're going to learn here. When you look at the rock, paper, scissors game in Automate the Boring Stuff, there is a lot of code there, and I want to show you how you get to that point. How do you get to the point where you have this long program with lots of code? Because it can feel kind of confusing on where to start. So let's get started. First off, comments. So we're going to add a hashtag or a pound sign, and we're going to write out my rock, paper, scissors game. Created by, and then put your name. Okay, so we know how rock, paper, scissors works. So let's add those rules up here at the top. Rock is greater than paper, or no, sorry, scissors. Rock beats. Let's do beats. And I'm already typing R, S, and P. R stands for rock, S stands for scissors, P stands for paper. So rock beats scissors. Scissors beats paper, P. And paper beats rock. Okay? Okay, so just anytime you're defining something like that, you want to kind of define what the rules are. So if paper versus rock, paper's going to win. And, when you have a more complicated program, you might write the overall instructions for your program up at the top. So I'm just thinking here in my head, did we cover every possible thing? Yeah, I think we did. So we're good. If we didn't, we'll figure that out in a minute. Okay, so to start, rock, paper, scissors, if you're playing against a computer, it needs to be able to randomly guess. But let's not worry about that yet. Let's start with the very simple, let's welcome the user to our game. So let's print welcome. Choose your destiny. I think that's how you spell destiny. I don't know. Maybe not. Choose your... let's just say welcome. Rock, paper, or scissors. Okay? And we don't want to have to deal with having the user type out rock, paper, or scissors. And then we have to write that in our code and deal with it. So what we'll just do is exactly like they did in Automate the Boring Stuff. We're going to write out for the user when they see this. Let's put it here. They'll just see this little parentheses, and it's just saying, choose R, P, or S for rock, paper, or scissors, right? So if we run that right now, it should just print welcome, rock, paper, or scissors, question mark. Now what we can do, let's go ahead and let's create a variable called user choice, and we'll just use input, right, to get the input. If you could tell, I'm not the best typer. So if you're not either, great. And if you are an awesome typer, good for you. But you don't have to be a great typer to get farther along in your career. So if we run that, now we're asking the user. So we could say like rock, and we've stored that in user choice. So we started here. This is the easy spot to start, right? So we welcome the user. We got their input. We're not playing rock, paper, scissors yet, but we know that if the user types something in at this point, but we don't really know what they typed in. So, for example, like if we just print out what they typed in, and I type in ASDF, it just prints that out. Okay? So right now we don't really have any good input validation to make sure if the user picked rock, paper, or scissors. So this is we're already kind of seeing that we need something more to check if the user did the right thing or not, if they picked an option. So what we need to do is check with a conditional statement. So we'll use if. So if the user choice is rock, then let's do something. Let's create an if clause. Then we'll just print you chose rock ... Okay. And let's create a second check conditional statement. So it's not another if, right? We don't want to do if again. We want to use elif. This way it's tied to this if statement. If we just wrote if again, then even if the first, user choice equals R is true, it's still going to check this one as well. And that's not very efficient because we know they can only choose one thing, right? So we want to use elif. That way this only gets checked if the first one, if user choice equals R, is false. So we're going to check if it's paper. Then print you chose paper ... elif user choice equals scissors. I'm just going to print you. Okay, I wish it would stop making that giant box pop up. You chose scissors. Okay. Okay, so let's just test that real quick. This is a great thing to do when you're writing a longer program, is just periodically stop and test your program and make sure it's working the way you wanted it to before you go on and write a bunch more code. So I write P, it says paper. S, you chose scissors. Great. So that's working the way we expected. But if we choose something else, it just does nothing, right? So we need to have another last case here. So if it's none of those choices, then we need to do something else. We need to say invalid option. Please choose from the available options. ... We're getting really ... dotty. Okay. So if we run that, I'll make that a capital I. And let's fix these ones so they're consistently capitalized. And if we run this, what did we do? Oh, look, we forgot our colon. And this is why I wanted to do live. Actually, let me not just skip that so fast. This is why I wanted to do live coding, because I just felt like it'd be useful for you to see errors that pop up and how you kind of work through actually writing a program that's longer and what it looks like to break that problem down into smaller bite-sized pieces. So we have this error on line 19. It says else, and it just points an arrow to the end of the else and says invalid syntax. So if we go down to line 19, it's pointing and saying, hey, there's something wrong right here. Invalid syntax. So if you take a look at it, it's like, oh, I forgot my colon. So just checking that error. So now if we run and we provide something that's not RP or S, we print out invalid option. Please choose from the available options. Okay, so we've got some input validation for rock, paper, or scissors. But if the user picks an invalid option, then it just stops. You know, like the game's over. Like we don't have an invalid option. So what we actually need is some kind of loop, right? A loop that's going to check and see, did the user enter rock, paper, or scissors as an option? If they didn't, then just keep them in that loop. Okay, so let's do about, let's create a Boolean variable. I think that would be nice to use. So this is a good example of using a Boolean variable. We'll say valid, we'll say is valid input, and we'll say is false. I'm just thinking through this. So is valid input, you know, you always want to start your Boolean variables off with is. So to start, it will be false. And then down here, we're going to say while not is, oh, I guess not, different programming language. While not is valid input, then we want to get the user input. So while we don't have a valid input from the user, basically, get the input from the user. So we gotta move all this over since we're now in the while clause, right? Okay, so let's try that. So if I type the wrong thing, invalid option, please choose from the available options. It'll just keep saying that until I pick a valid option. And actually, it's just gonna, so if I pick like P right now, it's gonna keep going. It's not, we're stuck in this loop. Okay, so stop. We need to break out of the loop. So one of the things we need to do is make sure that we turn this Boolean value to true. So if we change this to true, then not true is false, right? So if we get a valid input, so RP or S, then is valid input equals true. And we'll just do that for each of those. Okay. So now if we play that, ASDF, invalid option, invalid option. If I pick rock, okay, you know, now we're out of the program. See, if I type R again, it's like, hey, what are you doing? I don't know what that is. So we got out of the while loop, which is good. Okay. So now we have input validation taken care of for taking that initial rock, paper, or scissors input from the user. Okay. And now what do we need to do? All we've got is, you chose rock, paper, or scissors. Now we need to get the computer to make a choice. Okay. So this is where we're going to need to actually import random, right? And we need to actually, I'm going to say as R, no, as rand. I won't do that. I'll just do random. That's what all your reading shows anyway. So, okay. So we'll just say import random, and we'll come down here. And, just spoiler alert, we're going to have to move all this code over again, but I'm just showing you like kind of how you work through writing the code out. So, okay. We've got input. It's stored in user choice. User choice. We actually need to do user choice right here. I just noticed an issue. Okay, so if we do user choice inside of here, and then we come down here, let's just make sure. User choice. If I print it there. Okay, so it's still keeping track of it. That's good. Okay, so we got random. Let's get let's say it's called computer choice, and it equals random, rand int, right? We used that in the last video, and we know we can generate a number from 1 to 3. And that's a decimal, not a comma. Okay. So now that will generate a random number 1, 2, or 3. So rock, paper, or scissors. And we can say we need to translate that, right? We don't want 1. We want, if computer choice is 1, then let's set computer choice to rock. And if computer choice is 2, let's set computer choice to paper. We're basically just making it not a number anymore. And really here, since the only possible values are 1, 2, or 3, we could just say else computer choice equals scissors. Okay, and that actually kind of still works pretty good for us because, and I almost forgot that colon there again. Right there. Even if you change this number to 1 through 100, the only possible values that we'll set computer choice to are rock, paper, or scissors. So even if you did randomly have this set to like 100, it'll just be set to scissors, which it would be very predominantly choosing scissors, but do 1 through 3 and that'll work good. Okay, so we've got computer choice translated over to rock, paper, or scissors. Oh, we need to add quotes around these actually. That's funny. It might be a little late right now as I'm recording this. Okay. And I put equals equals there. So you want it equal, not equals equals. Because equals equals is equality, right? We don't want to check if it equals S. We want to set it to S. Okay. So now let's just kind of do the same thing as we have here, but instead we want to check for the computer. So if Well, actually, let's just go ahead and print it inside of this if. We don't need to check again. Let's copy this print you chose rock and put it underneath the computer chose rock and just say computer chose rock, you know? And then computer chose paper, right? And this is gonna be a random number, so that's the beauty of this. It will be different every time. We don't know if it's gonna be rock, paper, or scissors. And we'll copy this one and say computer, oh shoot, go right here. Computer chose scissors. Let's run that. See if it's working the way we want. Okay, so you chose rock, computer chose scissors. Okay. We're still not playing the game though yet, right? We got it. Now we have to compare the values. So in that case, I chose rock, computer chose scissors. I should have beat scissors. So here's where we add in that game logic. So we've now got, the user's choice, the computer's choice. Now let's add in the game logic to tell them who won. So as a matter of fact, I talked about comments, but I've just been kind of writing and talking to you, and I need to add some comments in here because this code is not very commented. So right here, we're going to say get user input and validate value. Should be R, P, or S. Okay? Is valid input will be set to true when user choice equals R, P, or S, right? Let's get some comments in here. Okay. I think that this kind of just reads naturally to me, so I don't think that really needs a comment. It doesn't ever hurt to add one. Okay, so let's say generate random number to get computer move. And let's add in 1 equals rock, 2 equals paper, 3 equals scissors. Okay? And let's see. Okay. Now let's define game logic and determine winner. Okay? So if the, user choice equals rock, and here's where we use some of that conditional logic. So conditional operators like and. So if the user choice is rock and the computer choice is scissors, then the player wins. Need those quotes. Player wins, right? All right, let's say you win. I think that sounds better. You wins. You win. Okay? And let's say else if user choice equals paper and computer choice equals rock. So we're going to do all the cases where the user wins first. Print. You win. Let's keep it the same. Okay. Okay. And L if user choice. User choice equals scissors. And computer choice equals paper. Again, we print. You win. Okay. All right, let's test that out. I pick rock. Computer chooses rock, so it's a tie. So we got the game's over. The program stops running, so we have to rerun the program. Computer chose rock again. That's crazy. I'm gonna choose rock again. Okay. So I chose rock. Computer chose scissors, and it says you win. Okay. And you might already be noticing it's kind of annoying. I wish I could play more than once without having to press stop and run. That is going to be one of the next things we add super fast. But let's go ahead and add in and determine winner. Okay, and let's just add some comments and say cases where the user wins. Cases where the computer wins. Okay, and let's add in, basically we just need to copy these, and we're actually going to keep this elif going. I just added a space between them, but these are all tied together. Does that make sense? Like they're all going together. Even though I have this extra space here, it doesn't make a difference. And we want that because it just makes it run faster. So if the user choice is rock and the computer choice is paper, then the computer wins. If the user choice is paper and the computer choice is scissors, then the computer wins. Yeah, we don't want to say win. That sounds weird. Okay, and change that one. Computer win. So when the user choice is scissors and the computer choice is rock, then the computer wins. Okay. And the last thing we need to do is just copy this one again and do the draw cases. So we can actually do this. We can actually just say else in all other cases. Let's just print draw. Okay. And let's add a comment that says that in all other cases, there was a draw. Okay. So let's run that. What do we? Oh, that's like the second time I've done that. Maybe third time. Okay. So again, I fixed the error without talking about it, but it's just I forgot this colon at the end of the else. Okay, so rock, paper, or scissors. I pick rock. We draw. The computer loves rock. Okay, I chose rock. Computer chose paper. Computer wins. Okay. So we could try one more time. Choose rock. Computer chose paper. Computer wins. You know, if I choose paper. Computer chose scissors. Computer wins. I'm starting to think this computer might be onto something. Hey, I chose scissors. The computer chose rock. It really is random, but that's pretty funny. Okay, so last thing we want to do, we have the full game working. Let's add in another while loop so this game just keeps running. And we just need to add in one more step here. So welcome rock, paper, scissors, or quit to allow the user to quit in between games. So we'll add a while right here. And we'll say while true. We're going to do something special here. Okay. So while true, so it's always true. And then we're going to use sys exit, which we talked about in the last video. So import sys, and we're gonna, I don't think this will let me. Oh, it does. So if you, on Windows, if you hold down Alt, right, and then drag your cursor down the front line here, you'll notice it stayed right there and didn't highlight anything. So if you press tab, it moves everything over once, which is exactly what we want. So everything's inside this while true. Okay, so at this point, if we run this and pick rock, we've already basically, it'll just go on forever now. You know, computer wins, computer wins, computer wins. Oh my gosh, that's insane. We can just keep playing over and over, right? But we don't give the user a chance to say they want to quit. So let's say rock, paper, scissors. Quit. And we'll just say Q. Okay? And then at the very end of this while, right? So we're going to process everything in this while clause. And then at the very end, well, actually, let's do it at the top. I don't know why I was thinking at the very end. So at the very beginning here, actually, we're going to check and see if they picked quit. Let's add it right here. This makes sense. So when we're checking if the input is valid or not, so we'll say elif the user choice equals Q, then they obviously want to quit. We're just going to say sys exit. So that's what we were talking about in the last video. So if we run that, I put in Q, we get the system exit. It exits the program. So otherwise, we'll just keep playing the game until I don't want to play anymore. And then I just press Q and it exits. Okay, so simple enough. And then the last thing that we could do, like they did in the book, is implement some scorekeeping. And we could just say, you know, wins equals 0, losses equals 0, draws equals 0. Okay? And right here at the beginning, we could say print, just for funsies. And we could say, we're actually going to do something like this. We're going to say wins that's already going to add a space for me because there's a comma. But I don't want to do that. No, I want to show you the using the string concatenation. So we're going to do string wins plus losses okay, right? So like, does that make sense what we're doing? Hopefully. We're typing out wins with the extra space and then a plus, and then we're turning wins, the integer, into a string, concatenating or adding that to the other string, and then we can just keep going and doing that. So now we did losses, and let's do plus again, and we'll say draws. Oh, went down to the bottom line. Plus string of draws. Okay. Let's run that and see if we mess anything up. So wins, losses, draws. Oh, okay. So nothing's broken yet, but we didn't actually increment wins, losses, or draws. So let's just come down here and we separated it all out where the ones where you win. So we'll just literally say wins equals wins plus 1. So we're just adding 1. We're getting the value of wins, which is 0 by default, adding 1 to it, and setting that value using the assignment operator to the wins variable. So just adding 1 to it basically. If I just said wins plus 1, that value that gets evaluated doesn't actually get assigned to the wins variable, so you have to assign it. And then for computer wins, we'll say losses equals losses plus 1, right? Okay. And draw, we'll say draws equals draws plus 1. So if we run that, let's see if we broke anything. I won and I get a win. So it's keeping track of how many wins and losses. And if you play this enough times, theoretically, you should, and we kind of are, you get the same number of wins, losses, and draws. You know, if you were to play this a million times, it would be almost no difference because it's random. But one last thing, you know, I noticed it seems kind of cramped between each start of the game. So let's come up here where it says welcome and just put \n. That's for a new line. So when it first starts, it's going to create an extra new line. See how we have that extra new line to start? I think that just helps kind of break up each choice. And let's also do that maybe right after user input. So no matter what, after we get the valid input, let's just print nothing. Oh, we still put it right there. Okay, you chose rock. Yeah, I don't like that actually. Let's not do that there. We'd have to do it here. Right after input. That I think will look better. Yeah. You chose rock, computer chose rock, draw. And then welcome. Okay. And then we could probably add one more thing. Let's come up here actually, and at the very beginning, let's type print, and let's just add in like some underscores to the end here. It's totally like your preference, but I think it'll be nice. And just move that \n to that. And let's try that. Yeah. I kind of want there to be a space before that new line. Or after that new line, rather. So let's add another \n right there. I think that looks pretty nice. So, rock. Yeah, looks good. Okay. And I don't use it very often, but I think there's a function called CLS. Let's see what happens if we call it. CL clear. Let's see what that does. No attribute clear. Okay, so that didn't work. It's tried to give me it. Clear screen? That's what I want to do. This has no module, no attribute clear screen. Well, it sure is thinking it does. I'm gonna pause research and we'll okay, so I'm glad I didn't put you through that. But basically there's OS as a module that you can import, and you can use os.system, and on Windows you can use CLS. And if we put this at the beginning of the for loop, then it'll always clear the terminal. So for example, it'll always look like this when we play, and it would just update the wins and losses, which would be kind of cool. But inside of Mu, it doesn't work. So if we save this program and run it in our regular terminal, it would do that. But I'm just going to stay in Mu because it's not that big of a deal. But if you want to, you could use this in Windows. And then for Linux, you would need to use clear instead. And that should work fine. I think it would be a nice little touch, but for the sake of Mu, we're not, it doesn't really do anything. You know, if I run this, and it actually slows down the program a lot, which is kind of unfortunate, but it would be cool because then this would just reappear at the top with the draws updated instead of, you know, printing all this all over again. So let me just pause this real quick, and maybe I will pull it up because I think it would be cool to show you. Okay, so I've got my terminal pulled up here, and I'm in the downloads folder where I have this example.py program saved. And hey, this might actually be kind of cool. We haven't really done this, but I'll show you how could you run a Python program directly from your terminal where you don't even need an editor. So when you installed Python, I told you to click on the checkbox that said add Python to path. So what that does is it allows me to open up a terminal, which I'm on Windows and I'm using PowerShell, but if you're on Mac, you could be in terminal. On Linux, you could be in terminal. It doesn't matter. They all pretty much function the same. With the new version of Python, it's added on the path and you type in py to access it. That means that anywhere, no matter what folder I'm in, it knows where Python is. That's what it means when it's added to path. So if I type in py, it starts Python right in my terminal. And just for your information, if you ever need to get out of Python, just type in exit and you'll exit. So you have to add in those brackets, exit, or not brackets, sorry, parentheses, and then it calls the exit function and Python exits. So Windows, I use clear, right? So you notice how clear cleared the screen. That's a little weird, but it's because PowerShell adds in aliases for Linux commands, so it's a little strange, but like normally you use CLS for Windows. So for example, ls is a Linux command that you could use here, but that's actually a Linux command, not a Windows command. But anyways, if I do py and I type in the name of my program, example.py, and I run it, okay, welcome, rock, paper, or scissors. So if I pick rock, you chose rock, and it resets. So losses is 1. You chose rock, computer chose rock. Computer wins. And it just keeps track. So it's kind of cool. And the delay is actually working in my favor because you have a chance to see if you win or not. If it's running really fast on your machine, you could actually use another function like sleep or something like that. But really, it's working fine for me right now. But if I wanted to, I could add in like a system, a call to make the program basically sleep and wait for a minute before moving on to the next iteration of the while loop. But it's working pretty good. So there you go. We made rock, paper, scissors. We keep track of the wins and losses. We've got a while loop. And then inside of that while loop, we have another while loop. That means it's a nested while loop. We got to try out importing some modules. We used some conditional logic with if, else ifs, and elses. Pretty much covered everything from chapter 2. Got to play around with it. Instead of doing a review, we actually got to create something with it. So hope you enjoyed the video, and I look forward to seeing you in the next one. Thanks.